Today we are going to look at operators. I think this is where we ended the last time. Is that not it? This is basically for those in Group A and C. We ended with operators. We didn't go into details. Is that not it? All right. So today we are going to look at operators. And when we talk about operators in C, we are basically talking about symbols, or a symbol that specifies an operation to be performed on an operand. Now, when we talk about an operand, the operand is basically the data items that the operators operate on. So assuming we have two variables, A and B, and we are to sum A and B, the operator in this case is addition. And then the operands are the A and B. Now, operators which require two operands are called binary operators. Binary operators. But in an instance where the operand is just one, then we call it a unary operator. All right. Now, depending on the operations we are going to be looking at, operators are classified as follows. We have arithmetic operators. We have relational operators, logical operators, assignment operators, increment and decrement operators, conditional operators, bitwise operators, and then size of operators. Now, in a short while, we will try to understand what these operators are and how they are implemented in C programming. When we talk about arithmetic operators, we are basically talking about operators that use arithmetics, like addition, subtraction, multiplication, division, etc. And if you want to find relationship between two or more items, or relationship between two items, in most cases, you are either looking at the items as being equal, one being greater than the other one, another one being less than the other one. Can you mute yourself or I take you out of the class? All right. So then when we talk about logical operators are basically operators that use the logical principles. So in this case, they use principles like the AND gate, the OR gate, the XOR gate. Then for assignment operators, what happens is that these are used to assign variables at every stage of our operation or at every stage of a certain task. Then increment and decrement operators allow for performing of operations where there will be the need to increment or do some addition or subtraction in terms of be it integers or bits. Then we have conditional operators, bitwise operators, and size of operators. So without spending much time, let's look at what arithmetic operators are. Arithmetic operators are used to perform mathematical calculations like addition, subtraction, multiplication, division, and modulus. We all know that the symbol for addition is the plus sign. So when you look at this table, you will see that the addition has its operator as the plus sign. And if we are to perform addition on two variables or on two operands, A and B, what we'll be doing is that we'll be having A plus B. For the operation subtraction, or for the subtraction operation, we have the minus sign. So in this case, its example will be A minus B. Similarly, for multiplication, because we don't have the option of using the multiplication symbol, we use the asterisk. So take note of that. Now, the asterisk, an example of doing that is having A asterisk B. That means that A multiplied by B. Then we have division. Similarly, we use the / to notify or to signify division. So in this case, A / B is an example of how division is performed. Then we have modulus, which is basically finding the remainder after division. So we use the percentage sign, which is A modulus B. So these are the various operators under the arithmetic operators, or the operations that are performed under arithmetic operators. Now, before we look at an example of how arithmetic operation is performed in C, we would need to understand some rules for arithmetic operators. Rule number 1 is that C programming allows only one variable on the left-hand side of any instruction. So for example, before the equal sign, you can only have one variable. So C equals to A asterisk B is what is legal to do in C programming. But you cannot perform it the other way around and say that A asterisk B is equals to C. That is not done. That is not workable. C does not allow that. So you take note of that. That is rule number one. Arithmetic operations are performed on the ASCII values of the characters and not on the characters themselves. Now, ASCII stands for basically American Standard Code of Information Interchange. So when I take a variable, say A equals to 5, anytime an arithmetic operation is being performed, it is not performed on the A, but it is rather performed on the 5. That is basically what this rule means. Operators must be explicitly written. If it is addition, you have to be very sure to write just one plus sign. Double plus sign means something different. Plus and minus sign also means something different. So you have to be very particular when you are writing the operators. Operation between same type of data yields same type of data. But operation between two integers, or operation between an integer and a float will yield a float. So assuming I have A equals to 4 and B equals to 5, and I am performing an operation, what will happen is that because these two are integers, A times B, which is 4 times 5, will give me 20. But if I am dealing with a float and an integer, say A equals to 4, B equals to 4.5, when I multiply this, I am going to get a float. Because B is a float and A is an integer. So in this case, what is going to happen is that my 4 times 4.5 is going to give me 18.0. Maybe I should pick a better float to deal with. Let's say A is equals to 4 and B is 4.1. So if we do 4 times 4.1, that will give us 16.4, which is a float. Please, do you understand? Okay. Now let's look at an example to further illustrate or explain how arithmetic operators work. In this example, as you are already aware, hash include stdio is our preprocessor directive. Int main, and we come down to declare our variables in line 4. Now, because we want all of them to be in the integer data type, they are preceded with int. So int m equals to 40, comma n equals to 20. Because we're going to be doing addition, subtraction, multiplication, division, and modulus, we have add, sub, mul, div, mod as variables that have also been declared because we are going to be using them. Now, from line 5 to line 9, you would see that all these instructions which will perform the arithmetic operations have been outlined. So line 5 will do addition, line 6 will do subtraction, line 7 will do multiplication, line 8 will do division, and then line 9 will do modulus. Now, once all these are done, how do you get to know that, or how do you get to know your output? To know that the operation has been successfully performed. That is where we have the printf, which we all know is an output function, which is used to display addition of m, n is, then it will give you the value. Subtraction of m, n is. So when you look at line 10 through line 14, these are basically there to produce the various outputs. So if you have taken notice of that, this is how arithmetic operation is done in C. Any questions? If you have a question, just raise your hand and then you'll be given the opportunity to ask your question. If there is no question, just give a thumbs up so that I can continue. Yes, Afrifa, you may unmute yourself and then speak. Afrifa, we are waiting for you. Unmute yourself and talk. Afrifa, you showed your hands up. Afrifa Naya Abdul. Okay, whilst we wait for that, Kunadu Bismarck, you can raise your, you can unmute yourself and talk. Yes, Kunadu. Kunadu, unmute yourself and talk. Your hand is up. Okay, Prempe Adomako. Unmute the microphone and then talk. Your hand is up. Is it the thumbs up button that you guys wanted to use that you are raising your hand or what? Yes, Prempe Adomakun, we can't hear you. Hello, is Prempe there? Okay, since they are not ready to talk, we can continue. Now let's look at relational operators. When we talk about relational operators, we are basically talking about operators that are used to compare two or more operands. We all already know what operands are. Operands may be variables, constants, or expressions in this case. So when you look at the operation greater than, we use the greater than symbol as the operator. When you look at that from the table, you would see that we can have m greater than n, and then in less than, we can have m less than n. Then if we are going to do greater than or equal to, we have the greater than symbol in addition to the equal to symbol. So you have m greater than or equal to. Similarly, we can have less than or equal to. Then if we want to say two operands are equal to each other, then we use two equal signs or two equal operators to show that these two operands are equal to each other. Now, if the operands are not equal to each other and we want to say not equal to, then we would have the exclamation and the equal sign together to denote that. Let's see an example quickly. Now, in this code, this is a simple code just to illustrate relational operator, where we are trying to find whether two integers are equal or not. So in this case, you have int m equals to 40, n equals to 20. And then you would see something has been used there, the if, and then the if used in line 5, and else, which has been used in line 9. This is something we call control statement. Control statement. Now, control statements are basically used to control the flow of our program. In some cases, they are used to perform some task based on certain decisions or certain relations or certain conditions. So we can classify these control statements into 3 categories. That is decision control statements, looping control statements, and then jump or jumping control statements, which we'll look at in chapter 4 in details. But for the purposes of demonstrating how relational operators work, what we are doing basically here is that if m is equals to n, then a certain task needs to be performed. So in this case, the task will be that there will be a print on the screen as m and n are equal. Anything apart from that will mean that they are not equal. So the else part of the code would present that as well. Any question? So here you see that at the if m and n uses relational operators or uses a relational operator of equal, which means that if m is equals to n, in line 7, it should print on the screen that m and n are equal. Else, m and n are not equal, which is printed in line 11. Any question? Any question? All right. Now, the next kind of operators we would want to look at is logical operators. Logical operators. And like I said earlier on, logical operators are used to combine the results of two or more conditions. And they use logical principles. It is also used to test more than one condition and make a decision out of these conditions. So if you take the table here, you would see that for the first one, where you have the operation logical and, the operators or the amber signs are used, double amber signs. So look at an example here. M greater than 5, all in bracket, and n less than 5, all in bracket. So in this case, a certain decision will be taken based on these conditions. And what will happen is that that decision can only be performed when both conditions, that is m greater than 5 and n less than 5, are all true. Then we have the logical OR. So like we said earlier on, it is used to test more than one condition and make a decision, or it is used to combine the results of two or more conditions. Similarly, in this example, you would find m greater or equal to 10 or n greater or equals to 10. And what happens here is that it returns true when at least one of the conditions is true. So a certain instruction or a task can be performed based on one of those conditions being true. Then the third logical operator is the logical NOT. The logical NOT. What the logical NOT does basically is that it reverses the state of the operand. It reverses the state of the operand. So if the operand is, say, a logical AND, in this case where m greater than 5 and n less than 5, you will see that before these two conditions are compared or combined, there is an exclamation sign. So if m is greater than 5 and n is less than 5 is true, because of the use of the logical operator or the logical NOT operator, this ends up making it false because it returns the opposite of the true state. So let's look at an example. Integer a equals to 40, integer b 20, integer c 30. If a greater than b, if a greater than b and a greater than c, then we can say that a is greater than b and c. Else, if b is greater than c, then we can say that b is greater than a and c. Else, c is greater than a and b. So you would see that in line 5, the logical operator has been used to set the initial decision. That is, if a is greater than b and a is greater than c, then line 7 will be executed. If this condition is not true, then it would now check this condition to see whether b is greater than c. If that is true, then it will print f b is greater than c. If line 5 and line 10 are not true, then by default, line 13 would be executed. So this is basically an illustration of how logical operators are used. Any questions so far? Yes. Kwamena Khalil.
Yes, sir. Please, I wanted to ask, can this coding be used in security system, like programming a security system?
Can you give more light into your question? Asking if it will be used in security system is a bit vague.
All right, so like, let's say programming a social app or social platform, and each for like account security purpose. Can you use this in the coding, like to separate the password and detail like a login ID or something? So if it's not telling you.
Right. Yes. So in this case, there is a login, a username that is already known, isn't it?
Yes, sir.
And then there is a password which has also been set.
Yes, sir.
So we are saying that the AND operator, which is the operator that uses the amber sign, the two amber signs, is used to return an output when the two conditions on the sides are all what? True.
Equal. Okay.
So in this case, what will basically happen is that the integers would be the username and then the password.
Okay.
So it is basically just going to be if username equals to, then the username is there. And password equals to, then the password is there. So in this case, instead of the greater than symbol, it's going to be equal signs. And then the various password and then the usernames are assigned, and this would work. So that is a perfect example. Thank you for that.
All right, thank you, sir.
All right, any other question? If you have any question, kindly raise your hand. You would be given the opportunity to ask the question. If there is no question, then we'll proceed to the next operator, which is assignment operators. Assignment operators. Now, assignment operators are basically operators used to assign a value or an expression or a value of a variable to another variable. So when you look at the syntax for assignment operators, you would have a variable name being equals to an expression or a value or a variable. We would have a C code to demonstrate that very soon. So example, X equals to 10, Y equals to A plus B. So here, X equals to 10 is assigning the value 10 to X. Y equals to A plus B is basically assigning the expression A plus B to Y. And then Z equals to P is basically assigning the variable P to Z. So C provides compound assignment operators to assign a value to variable in order to assign a new value to a variable after performing a specified operation. So what this means basically is that in the sequence of a code, there could be an instance where you can have the value of a variable or a value assigned to a variable. And then as the code goes, you go through the sequence, there is reassignment of that variable again, but it is not the same value, but an updated version of that value. We'll look at an example very soon. So when you look at the operators used for assignment, you have plus equals to, which with an example, when we write x plus equals to y, would mean that x equals to y plus x. And then when we have y minus equal, where we have x minus equal y, that becomes x equals to y, x equals to x minus y. Then for multiplication, we have asterisk equal, where x asterisk equal y, and that means that x equals to y asterisk x or x asterisk y. Then we have division, where you have the forward slash. So x forward slash equal y means that x is equal to x divided by y. And then for modulus, we have the percentage sign and equal. So you have x percentage equal y, which means that x equals to x modulus y. So this is assignment operator. Now let's look at something here and see how the assignment operator has been demonstrated in a code. So in this code, you will see that we have integer a equals to 5, and then we have another integer c. Now, the integer c does not have a value, it's just a variable. But integer a equals to the value 5. Then we start off by assigning a to c. So in line 6, c becomes a. So if this is executed, c is going to be 5. Then in line 8, c plus equals a means that c is equals to c plus a. That is the c in line 6 plus the a that has been defined in the variable. So you realize that because in line 6, c is already 5, if we are going to have c equals to c plus a, it's going to be 5 plus a, 5, and that will be 10. When you take your time to execute this code using your code blocks or using your mobile C or coding C app on your phone, you would see these values. Then when you move on to line 10, where we have c minus equal a, which means that c equals to c minus a, at this instance, c is 10. So c minus 5 would give you 5. So the new value for c becomes 5. That is for line 10. And then when you move on to line 12, where you have c asterisk equal a, what this means is that c equals to c asterisk a. And now at that point in line in line 10, our c is 5. So 5 times a, which is 5, would give us 25. So the new value for c is 25 at line 12. Then when you move on to line 14, where we have the forward slash equals a, which means that c equals to c divided by a, that would mean 25 divided by 5, and that will give us 5. And 5 now becomes the newly assigned value to c. And then when you move on to line 16, you have c modulus equal a, which means that c equals to c modulus a. So now, since c in line 14 is 5, if we divide 5 by 5, the remainder is 0. So our modulus now becomes 0. So c in line 16 becomes 0. Please, do you understand?
Yes, please.
Please, can you go over for us? I don't catch up with that.
What didn't you understand?
Coming from the line 7 coming, I couldn't catch up. I was a little bit confused as you started from there.
Okay. Obed, what is your question? Can you speak up so that we can hear you? We can't hear you. Please. You are speaking to an audience, so talk loudly.
Please, I was asking why 5 divided by 5 is equal to 0.
Before I answer the remaining questions, let me answer Obed's question. Obed, when we say
Yes,
we are
sir.
finding the modulus of something, what does that mean?
Sir, please, we are finding remainder.
Remainder, isn't it?
Yes,
so,
please.
Since we are finding the modulus C modulus A, the only way you can find the remainder of something is to divide them and see what the remainder is, right?
Yes, please.
So that is the reason why I explained saying that since C at line 14 is 5, if it is divided by A, which is 5, even though that will give us 1 as the answer, the remainder, which is the modulus, is 0. Is that clear now?
Yes, please.
Okay. Kwaku, what is your question? I want to see if your question is related to what they asked earlier on, then I can lump them all up. Kwaku, you can talk.
All right, sir. So my question was that C is equal to A on line 6. Why don't we declare it over there on line 5 rather? Because
why
the
don't
program
we
doesn't
declare C equals to 5?
A. C is equal to A. The C is equal to, you see, on the line 5, the int A is equal to 5, and then C, the column. But then per my understanding, the program does not know the value of C yet. So if you are putting C is equal to A, then that value over there is what the program will be using, right? So
yes.
aren't you supposed to bring the C is equal to A up there with the declaration part of it?
We did the declaration of variables.
Yes, please.
Okay, so this is the reason. Now, we know the value for A, but we don't know the value for C. This is the reason being that we are going to be performing several operations or several assignment operations. So the value for C is not going to be constant. It keeps varying. If you look at, or if you paid attention to the explanation I gave earlier on, you will see that in line 6, C is equals to 5. But when you come to line 8, C equals to 10. In line 10, C equals to 5. So because our C does not take a unique value, that is why we didn't declare C equals to 5 as the integer declaration section.
Okay.
So that C just becomes a holder which would hold the results of the subsequent operation. So you realize that throughout the code, the C or the value of C keeps changing, or it's being updated. However, if we had done C equals to 5, throughout the code, we would have a challenge because C cannot be updated to be 10 when it is performing another function. That will mean that we'll have to change the variable C to another variable if we want to do it that way. Please, do you understand?
Yes, sir. I get it now.
Okay. Now, the person or those people who said they don't understand this principle here, what we are saying basically is that in assignment operators, you either assign a value to a variable, you either assign an expression to a variable, or you assign a variable to a variable. Now, this illustration of a C code here is just for us to demonstrate the various assignment operators. That is assignment operator using just 1 second. Where is this then? So when you look at this diagram here, or this table here, look at how the various assignment operators are illustrated. So for addition, you would see plus equals to. So because we are dealing with an assignment operator, you would see the equal sign throughout. And for each and every one of them, the meaning is illustrated. If it is x plus equal y, what it means is that x equals to x plus y. If it is minus, you have x minus equal y, which is x equals to x minus y. Like that. So what we are basically saying here in this code is that integer a equals to 5, another integer c. These are all variables that we have declared. And because we are saying a equals to 5, the value for a would never change throughout the code. It will be the same throughout the code. However, because c has not been assigned any value, we can use it to illustrate our assignment operators by assigning some expression or values to it. So in the first instance, in line 6, we say c equals to a. And we already know in our variable declaration that a equals to 5. So in line 6, c automatically becomes equals to 5. Then in line 8, where c plus equals to a, means that c equals to c plus a, we are taking that c from line 6 and we are adding a to it. So in this case, c in line 6, which is 5, plus a, which is also equals to 5, will give us 10 on line 8. Then in line 10, because the current value for c is 10, if 5, which is a equals to 5, is subtracted from that, we would get 5 for the value of c in line 10. And then in line 12, because c in line 10 is 5, if we multiply it by a, we would get 25. Then in line 14, because c is 25 in line 12, if it is divided by a, which is 5, we would get the current value of c to be 5. And then in line 16, where we are supposed to find the modulus of c and a, c in line 14, or the current value for c, is 5. So if we are finding the modulus of c and a, what it basically means is that when we divide 5 by a, what is the remainder? So in this case, our c in line 16 would become 0. Is that clear now?
Yes, sir.
All right.
Yes, please.
Thank you very much.
Now we can continue. Let's look at bitwise operators. Bitwise operators. Now, bitwise operators are used for manipulation of data at bit level, and it operates on integers only. I am sure in your second semester or in your second year, you are going to be dealing with logic to digital electronics. And then you would be dealing with the logic gates and the binary systems, where you'll be dealing with a lot of zeros and ones. Okay, so you do something we call binary addition, binary multiplication. That is for binary arithmetics. Then you do logical operations where you have AND, OR, XOR, NOT. You have the ones complement. Based on certain conditions, you would be doing shifting of bits, either shifting to the right or shifting to the left. So these operations where you do bitwise AND with just the single amber sign, what this means basically is that X and Y, we would normally get 1 as the output when both inputs are 1. Now, just to give you a little understanding, let me see if I can do some little illustration for you. Let's go to the whiteboard. Can you see my whiteboard? I guess no.
Yes, sir. Please, I can see it.
Okay, don't worry. I'll show it to you very soon.
Okay, thank you.
See my whiteboard, right? Now you can see a white. So when we talk about the AND gate, the AND gate looks something like this, a 2-input logic device. So if this is A and this is B, and this is the output Y, because it's a 2-input binary device, a logic device, we can get 4 possible combinations at the input. So this is basically 2 raised to the power 2. This stands for the fact that it is binary. And this stands for the fact that we have 2 bits at the input. So this will give us 4 possible combinations. So here, if we are to look at the possible combinations for the input A, B, and then the output Y, this can have only 2 states, either 0 or 1. This can also have either 0 or 1. So for the first state, A, when A is 0 and B is also 0, we can also have another state where A is 0 and B is 1. A is 1 and B is 0. And then the last state, 1, 1. Now, what we are saying basically is that the logic AND would produce an output to be 1 here when these 2 inputs are all 1. That is the bitwise operation using the AND. What this means basically is that Y is equals to A and B, sort of multiplying each other. So 0 and 0 will give us 0. 0 and 1 would give us 0. 1 and 0 will give us 0. We would only get true as the output when the inputs are all 1 or equal to 1. So this is basically just a little explanation into logic gates. Now, I shared with you at the very beginning of the semester called Taraja. And when you go to part 4 of that material, there is a topic on logic gates. So spend some time on that and then read about logic gates. That will give you better understanding into bitwise operators. Yes, Bonnie.
What about those who didn't see the white screen that you showed? Because we can't see anything in your screen.
Oh, you didn't see the white screen?
Yes, please. And even the
All right. So with that understanding, the AND logic gate basically when you take the truth table, like I have shown in that diagram, you would only get 1 when both inputs are equal to 1. And for the OR, you would get 1 when either of the inputs is equals to 1. And then for XOR, you would get 1 when one input is 1 and the other is 0. And then when we talk about the ones complement, which is being illustrated with the minus X sign, what will happen here is that you are changing all ones to 0 and then all zeros to 1. That is what the ones complement does. And then the shift left, where you have X less than Y, would give us X being multiplied by 2 raised to the power Y number of times. So like I said, 2 raised to the power n, or 2 raised to the power of a certain number of bits, is what we are basically talking about here. And then similarly for the shift right, which is denoted with the greater than or the double greater than sign, would get X divided by 2 raised to the power Y number of times. So that is the bitwise operator. So here, similarly, we have a simple illustration where we want to check the least significant bit of a number using the bitwise operator. So when we talk about least significant bit, we are talking about, we have the most significant bit and then the least significant bit. In this case, we are talking about binary, zeros and ones. So as we move from the right to the left, then we are going to the most significant bit. So the most significant bit is always on the left, but the least significant bit is always on the right. So with this code here, int num, print f, enter any number, scan fd, then that summation symbol you see here is just basically trying to create a memory location or an address location for number to be stored. So if num and 1, then we are talking about LSB of the integer is 1. Else, that will mean that num ampersand 0. So the least significant bit will be set to what? 0. So basically, this is just an explanation of this, but you'd better understand this with more understanding into digital electronics when you deal with bits, Boolean expressions, etc. So I am not going to spend so much time here. This is also another example, which is used to toggle n bits of a number. So you have integer num n and then new number. So for the first instance, print enter number to request number. If the number is entered, it toggles between 0 to 31. And then it says that the new number is equals to num power or num raised to the power 1 less n. So here you realize that the bitwise shift to the left has been implemented. Similarly, you would see that the ones complement has also been implemented here. Another example has been given where it is used to count trailing zeros in a binary number using bitwise operators. So you can just take your time and go through these examples. Now let's look at increment and decrement operator. These are basically used to either increase or decrease by 1, a value by 1. So we have two types or two variants of the increment as well as the decrement operators. So for the increment, we have the pre-increment and then the pre-decrement. That is for the pre. And then we have post-increment and post-decrement. So when you have plus plus with a variable name, then it means you are trying to implement a pre-increment. So example, plus plus A. Then if you have a variable name with the plus plus in front of it, that is a post word increment. Similarly, for the decrement, it will be done using the negative symbol. That is minus minus as prefix, and then minus minus as postfix. So let us consider an integer value, say integer a equals to 10. To increment by 1, we can use either a equals to a plus 1, or we can say that a plus equals to 1, or we can say that a plus plus, that is for post increment, and then we can say plus plus a, which is for pre-increment. Both prefix and postfix does the same task of incrementing or decrementing by value of 1. Now, when it comes to evaluation, there is a slight difference in the order of evaluating this. Prefix first increment or decrement its value, then returns the results. Whereas postfix first returns the results, then increment or decrement the value. So now let's look at an example to explain that further. Here we have an integer a, b, c. A equals to 10. B equals to plus plus a. What this would mean is that a equals to 11 and then b equals to 11. That is for the prefix. Now, when we look at the postfix, it says that c equals to a plus plus. What this means is that a is 12 and then c is 11. This just comes to explain the statement here, which says that prefix increment or decrement value, its value then returns the results. However, postfix returns the results, then increment or decrement value is also returned. So this is basically an example to illustrate the same. Then we have the size of operator. Size of a data type is machine dependent and vary from compiler to compiler. Now, in programming, in some instances, there are situations where we need to know the total bytes that the type occupies within the memory, say an integer, a float, a character. So to find the exact size of the type in C programming, we use the size of operator. And this is a special operator that is used to find the exact size of a type of data or a data type within the memory. As we progress in the subsequent units, we'll see how well this is used. Size of operator returns an integer, that is total bytes needed in memory to represent the type of value or expression. The size of is much used operator by programmers. It is very useful for developing portable programs. So for the syntax, you see size of, which is used in various ways. You see size of, then the type, size of variable name, or size of expression. So this is also an example where this has been used. So you see integer variable, print the size of character equals to size of character. Print the size of integer equals to size of integer variable. Print the size of expression into brackets 3 plus 2.5 equals to size of 3 plus 2.5. So this is basically just a way of finding the size of a data type within the program. Now, before we move on, we have looked at the various operators in C program. That is from arithmetic operators, logical operators, relational operators. We've looked at what else? Can you name them? All the operators we have looked at today. Arithmetic, logical,
Assignment operators.
assignment, relational, bitwise, size of. These are all operators in C programming. Now, let's look at, or let's further look at variables and expressions, which we looked at briefly before we started with operators. And if you remember, we have always said that variables are used to represent some known or unknown quantity in memory. And variables are basically referential name given to memory location holding our program data. So what it means basically here is that the variable is not the memory itself. It is just the name given to what? The memory location. So in C, variables are typed in nature, which means we need to explicitly specify the data type of the variable at the time of its declaration. So if you have noticed, wherever there is a declaration of a variable, if it is an integer, you see int then the variable name. Now, there are two ways you can also access data stored within the memory. It's either by their memory address or by their variable name. Variable names are also termed as identifiers, if you recall. As such, they have to follow the identifier naming rules strictly. Now, apart from these identifier naming rules, which are used for naming variables, let's look at some quick points that we should always consider in naming variables. The first one is that the C language is a case-sensitive language. So we should be very mindful of how we interchange or how we use our cases. In addition to that, the C compiler treats uppercase and lowercase variables differently. So for example, NUM in small letters is not the same as capital N, small u, and small m, or NUM all in caps. These are all different. So you cannot have two variables with the same name in the same scope. So if I have two numbers, instead of just writing num, I am supposed to differentiate them with, say, num1 or num2. A variable must not be a global identifier. It cannot be a keyword. Now, in declaring variables, anytime you are writing any code and there is the need to use a variable, it is always advisable to declare the variable before it is used. That is why if you look at when we're looking at the assignment operators, the C was declared even before its usage, even though nothing was assigned to it. But just because of the fact that the C variable or the variable C was going to be used later on, it had to be declared for future use. So note that variable declaration informs the computer or the compiler about referential name that we are using for a memory location. Now, if you read some literature, they will tell you that variable declaration allocates memory, but that is not true. The ANSI standard for C or the ANSI C standard hasn't specified anything about memory location at the time of variable declaration. It is the compiler that plays with that situation. In other words, it is the compiler that performs that action of memory location or allocation of memory. So the compiler is smart enough to generate efficient code. And so it may allocate memory for the declared variable or can even ignore the declared variable completely. So variable declaration is not equal to memory allocation. Kindly note that. This is basically a syntax of how variables are declared. So data type must be a valid C data type, either primitive or derived. or user defined, which we looked at earlier on. You can also declare more than one variable of the same type at once using comma, which we have done severally. So you see, for instance, int num1, num2, num3. So the data type, the variable name 1, comma, variable name 2, comma, to the nth variable name. So we can also cast our variables based on their data type. So you see int num1 basically means the data type is an integer. Double principal. Principal is the variable name. The double is the data type. Float, time, comma, rate, comma, SI. Time, rate, SI are all variables. And float is a data type. Now, one thing you should know is that programming is an art, and so is variable naming. So you are free to give your variables any name you so wish, but you have to do it with clarity. And so there should be meaning in the variable names you decide to choose. Unless you are dealing with variables that would pick values, never declare variables like int x, x1, y, z, a. Instead, use meaningful variable names such as int sum, average, num1, num2. This makes your code readable. So kindly take note of that. Now, let's look at expressions in C. Expression is a combination of one or more operators, variables, and literals. And in most cases, every expression will evaluate to a certain data type. It would evaluate either to an integer, a float, a double, etc. So for instance, the expression you see sum equals to num1 plus num2, you would see that the equal and the plus signs are used here. And then we have the literals as well as the variables. Or you can have a complex expression where you have 1 plus x into bracket raised to the power n equals to 1 plus nx divided by 1 factorial plus n into bracket n minus 1 times x squared divided by 2 factorial, like that. Now, one thing you should note is that unlike mathematics, programming does not follow the principle of BODMAS for evaluation. So please take note of that. As you deal with expressions in C, you need to remember these. C does not support any exponential operator. So do not ever confuse the symbol, the power symbol for power or exponential. Rather, we use POW into bracket the base comma, the exponent. And this can be found in the math.h library. Similarly, in C, we don't have the root operator. So whenever you want to use square root, you type sqrt into bracket the function. And this is also in the math.h library. The math.h library is used to evaluate trigonometry functions. And so do not forget to group expressions within a pair of parentheses to prioritize its evaluation. So anytime you are having to deal with expressions where there are parentheses, remember to group them so that evaluation can be prioritized. Again, do not forget to cast integers to float or double before division to get fractional results. So when you anticipate that you are going to get a result which is a float or a double after performing division, you would have to find a way to cast those integers or variables into either a float or a double to ensure the results are properly casted. Now, these examples are expressions that I would want you to take your time and then write them in C. So this is going to be assignment number 1 for all of you. I am not going to take it, but spend some time and try to see if you can write these expressions 1, 2, 3, 4, 5 in C. In my next class, anyone who has done it can bring it up for discussion. Now, let's look at how constants are defined using constant in C. Constants are fixed value variables. That is, those values that cannot be altered throughout the execution of a program. And this value is always known as a literal. You can define a constant for any type, and they will behave like variables. And expect that they are read-only. Once assigned, they cannot be modified. Now, C supports 2 types of constant definitions. That is using the constant keyword or using the define directive. So let's look at something here. Consider a program that is being used to calculate the area of a circle. So when you look at the right hand, you see a code which is being used to calculate the area of a circle. Now here, pi is declared as a normal variable. What this means is that the value of pi can be modified anywhere within the program, but pi is a mathematical constant. And so declaring constants restricts the value from being altered. So even though this code you see here seems to be a neatly written code, it is not a good code because pi is a mathematical constant. So as such, it needs to be defined using a constant. So here, improving on that previous code, we would have a code like this, where constant float pi is defined before its usage for the calculation of the area of the circle. A variable declared with constant keyword is marked as read-only, like I said earlier on. the compiler would always look for modification of read-only variables and report errors if any of such is found. So if we want to define constants, we can define them using the constant, that is constant data type, then the constant name, then the constant value will come. Or the data type, constant, then the constant name, then the constant value would come. So for an example, we can have constant float pi equals to 3.14159f. Or we can have float constant e equals to 2.71828f. So these are all ways of defining constants. Now, using the predefined or the preprocessor directive, where we use the hash define to define constants, it also defines the compile time to be constant, and it guarantees 100% constantness. Unlike using the constant keyword, here it does not define any variable and does not consume memory. Rather, during the compilation process, the compiler replaces all occurrences of the defined constant with its literal value. So we can also call it the compile time constant. That is when we use the preprocessor directive. So in this case, you would see that after the hash include stdio, you have hash define pi 3.14159. And so at this point, anywhere within the code where the constant will be used, it will just go straight ahead to pick the literal. And at all times, when you have used the hash define syntax for constant declaration, it is advisable that the variable name always be in caps. Typecasting, which we looked at or we have spoken about severally, is basically a way of converting variables, constants, or expressions from one type of data or one data type to another data type. So conversion from one type to another is something that is very common in programming. There are instances where you would be dealing with integers, but at the end of the day, your results would need to be a float or a double. So let's look at this example here, just to illustrate typecasting in C. So we want to find the average of 3 numbers. And even though the numbers are all integers, their average is giving us a float. So you see int num1, num2, num3, and then the float has been casted. So the average, which is the result, the average of the 3 numbers, has been casted into what? Float. So at the end of the day, the average would be a float. So in C, there is what we term as the implicit typecasting and the explicit typecasting. Implicit typecasting is automatic, and this is done by the compiler, and it will convert it to the lower type, or it will convert the lower type to the higher type whenever required. And the automatic type conversion done by the compiler uses the integer promotion rule, which means that the compiler will automatically set the data type to an integer. Then we have, so this is what we are talking about. Then we have the explicit, which is the manual conversion from one type to another type. Here we have full control over the conversion. So when you look at the syntax, the new type and then the variable expression literal, where the new type must be a valid C data type. So the example we looked at earlier on where there was the usage of, or where we performed the average of 3 numbers, that was done using the explicit typecasting. Now, explicit typecasting can also result in some, that is when you are converting from float to integer, you will lose the decimal part of data. So you have to have this at the back of your mind so that you know how to deal with things moving forward. We have used these input and output functions in C throughout the beginning of chapter 3. But let's look at what these input and output functions in C are. So the input process and output process data is the main goal of every computer program. And a program without data is as useless as anything. So with the header file stdio, which is the standard input-output header, it contains various input and output functions. And so in order to be able to perform any of the input and output functions, you must always have an include statement at the top of your code. So you have the #include stdio.h. So if we want to deal with characters, or if we are dealing with characters, we have the input and output functions that are used for characters. That is getChar and putChar. So for getChar, it is the function used to read single character from keyboard. So it is an input function. The getChar function returns an integer, that is the ASCII value of the input character. That is the American Standard Code for Information Interchange. Then the putChar function is a display function. It is used to display or output a character on the console or the monitor. So kindly take note of that. So an example has been illustrated here to demonstrate the character input and output in C. So we use getChar and putChar. So this is a code that is used to demonstrate input output using getChar and putChar. So you have int main, then character grade as a variable declaration. Printf is used to request for input of a grade, and then the grade is equals to getChar. That is to accept the character. Then the character is displayed using the putChar, which is the output function. Now, using scanf and printf is also something we have used. So scanf is a versatile function to read input from standard input devices like the keyboard. It can input any primitive or derived type. It accepts strings containing lists of format specifiers. So we also have printf, which is used for output or to display output to the monitor. And so these are also examples to demonstrate how scanf and printf are used. So this brings us to the end of Unit 3. And I hope you have had an informative session